Now, good day, viewers. Once again, we give thanks to Almighty Allah for keeping us and guiding us up to today. So today, before we move on, we first of all give thanks to Almighty Allah and those that teach us and those that I met within this system, which are my colleagues and likewise my senior colleagues and those who are yet to come, who are yet to join us. So I give honor to them, I greet you all. And likewise, I greet my parents and my teachers, my principal, for giving me the opportunity of doing all what I'm doing presently. I give their honor to them. And most especially to my beautiful wife that has been with me and has given me the grace and the opportunity who gave me beautiful children. So I give her to her honor. So now, let us now back to our business. The subject we are having today is mathematics. And what do we have in this mathematics? We are starting from logarithm. These are the main subjects as well, or main topic that has already been giving a student a problem within the society. They find it out to be very, very difficult, and likewise they always mix it up. That is logarithm which are less than 10 and which are greater than 10. They mixed it up. So now, if we now say what we are doing now, we have a logarithm here, that is logarithm of number, which are the logarithm of number base 10. That is, if what we are going to have within our subject matter at the end of this topic, we should be able to solve what logarithm of number to base 10 is, and multiplication and division of numbers using logarithm table at the end of all this. Now, to now start with example, if we have y is equals to n raised to power x, then we can now cross it over. We can now say that it is this x is equals to what? Log what? Same log n raised to power y. Now, if we have y is equals to 10 base x, then we can now say x is equals to log 10 raised to power base y. Thank you. So now, this definition now takes us to, by saying that we have log 10 raised to power 1000, which is equals to what? 3. That is, if in standard form, we are going to have, we have what now? What? We have 1000, which is equals to what? 10 raised to power 3. So that is when we have what? Our 3. So since 10 base 3 is equals to 1000, then log 10 base 100 is equals to what? 2. Since we have what? Since we have 10 raised to power 2, which is equals to what? 100. Now, example. Express the following in logarithm form. Then, A, we have what? We have 2 raised to power minus 6, which is equals to 1 all over 64. B, 3 raised to power 5, which is equals to what? 24, 3. That is 243. C, we have 5 base 3, which is equals to 125. D, we now have 10 base 4, which is equals to what? 10,000. So now, how do we solve it? From our formula here, we now say 2 raised to power minus 6, which is equals to 1 all over what? 64. So we can now say that, well, then look at A now. We have y is equals to what? N raised to power x. Then we now have x is equals to log n raised to power what? Y. So it implies here, we can now say that what? We can now say log 2 log 2 raised by what? 1 all over 64 is equals to what? Minus 6. So now 3 raised by 5 is equals to what? 243. So we can now say log 3 is equals to 243 is equals to what? 5. Then 5 raised by 3 we can now say is equals to 125, which is equals to what? Log what? Log 5 is log 5 base what? Base 125 is equals to what? 3. 10 raised by 4 is equals to 10,000. We now say log 10 raised by what? 10,000 is equals to what? 4. So now, we now come down to what? Example 2. Express the following in index form. Index form, that is to say, whenever we are having it, we express it as what? As an index. So now, what is the index? We can now say, let us see example. Example, a log 2 raised by 1 over 8 is equals to minus 3. Let us now see the solution here. We have log 2 raised by 1 over 3 is equals to minus 3. Then we can now say 2 raised by minus 3 is equals to 1 all over 8. If we approximate 8, we now have 2 words. If we approximate it, we have 2 raised by 3. So if we now take log of both sides, therefore we can now have what is known as what? 2 raised by minus 3. Because here we are having 1 over 8. So far we are having 1 over 8. We can now say minus what? Minus 3. That's how we have what? Minus 3. Are you getting? Or apparently we can now say, let's say that what we have log what? Log 2 1 all over 8 is equals to what? Minus 3. So we can now say here, we said log what? Log what? Log 2 is equals to what? We have, no, 1 over 8 is the same thing, as to say minus 3. That is, if we factorize 8, we are going to have 2 raised by minus 3. If we are factorizing this 8, we have 2 raised by minus 2 raised by 3. But this 1 all over is what? Is the same thing as what? Minus 3. So if we now cut what? We cut the base form. This will give us this. And there is a law in log that says that log what? Log a raised by a is equals to what? 1. Or log what? Log 10 raised by 10 is equals to what? 1. So now, if we have log 2 raised by 2 here, that is what? 1. So therefore, we now have minus what? Minus 3. Do you understand that now? So, to now proceed. Let's proceed. Now, 2. We have log 10 raised by 1 all over what? 1 all over 100 is equals to 2. So, by so they saying, you can now say, then we now have 10 raised power because of, remember, I said because minus 1 all over, because of the division there. So, we will now have what? Minus. So, we now have what? Then we have 10 minus 2, which is equal to what? 1 all over 100. Is that taken? Do you understand that? Should I proceed? C. We have log what? Log 4 raised by 64 is equals to 3. We factorize 64. We have 4 raised by what? 4 raised by 3. If we now put that, we now have what? 64. So here we have log 5 raised by what? 625, which is equals to what? 4. Factorize this, we now have 5 raised by 4, which will now give you what? Which will now give you 625. Log 10 raised by 1000, which will now say that what? 3 is equals to 3. Therefore, then log 3 is equals to 1000. Now, note in this, note, we have logarithm of numbers to what? To base 10 are found with the help of logarithm table. That is, if we are solving logarithm which are what? Which are greater than base 10, we are using what is now what? Logarithm table. There is no how we are going to solve it without using what? Logarithm table. So example, use the table to find what? To find the log of A. We have what? 37. B. 3900 to what? To base 10. So in this, we now have 1. 37. So if we are using 37, apparently, if you remember during your standard form, while you have been taught standard form, you were taught what is known as if we have 10, that is we have what? 1. Yes or no? Okay. Now, if we now have that is this is what? Raised power 0. So if we now have what? If we now have 100, that's what? 10 raised power what? 2. Isn't it? If we have 1000, that is 10 raised power what? 3. Thank you. If you have 10,000, that is what? 10 raised power 4. So in standard form, that's what implies. We'll first of all look at what? Their difference, their characteristics, their index. So if we now look for the characteristics here, we now say that what? It's what? 10 raised power 0, which is what? 1, 10. Are you getting now? So now, as it is ordinary, we can now say 3.7 times what? 10. So which is known as what? 3.7 times what? 1 in what? Standard form. So now, if we now check within our 4-figure table, we will now check 3 under what? 7. We will check 3 under 7. What is it going to give us? It will now give us what? It will now give us 0.5682. Are you with me? So now, so from here we can now say that from what? From our table we can now have what? We can now have this. So that is from our periodic. That is from our logarithm table. So now hence we have log 10 raised to power 37 is equal to 1.5682. The next one we have, if we are asked to find 3900, how do we do that? We'll first of all look for what? For the characteristics there. The what? The standard form there is known as what? 3.9 times what? 10 raised to power what? 10 raised to power 3. So in standard form. Now, in what? In our periodic table, we will now check that 3 under 9, different what? 0. So from there we now have what? We will now have this. So because of the difference, which is what? 3, we add 3 to it. That is 3.5911. Is it clear? Now, remember, because of the difference here, the standard form here, because of the difference, that's why the what we had it here. Do you get now? So now, because of the difference here too, that's why we have what? We have 3. So we now add 3 to this. So this is what is given. So therefore, we can now say that what? In logarithm, that is log what? Log 3900 will give us what? Will give us 3.5911. So now, in logarithm, there are definitions. That is, for us to identify the numbers in logarithm, there are ways in identifying them. If we don't want to call them by their what? By the position where they were standing, we call them by the names of the position which they were standing. How do I mean? Let us see. Here we have 3.5911. 911. So now, what is the position of this 3 here? This 3 is telling, because of the decimal point in between, is now telling us that what? 3 as a whole, E is standing as what? Integer. E is an integer. So after decimal point, that is before the decimal point, we have the integer. After the decimal point, what do we now have? We now have decimal what? Decimal fraction. Because we can easily take them by now saying that they are what? 5, we have point what? 5911. Okay, after the decimal point, we take it 1. Oh yeah, now after the decimal point, how many numbers can we count? 1, 2, 3, 4. We represent 1, 2, 3, 4. That is why they are being what categorized as what? Decimal fraction. Is that clear? If we don't call them decimal fraction, we call them by their Greek name, which is known as what? Mantissa. Mantissa. Is that clear? So now, we now proceed. Example, we look at the example. Example, use the logarithm table to find the logarithm to base what? 10 of 51. If you look at this, they are what greater than what? 10. That's why we say that what in logarithm. Greater than 10, we use what? 4-figure table. The one less than 10, that's when we solve in this form. Is that clear? So the one greater than 10, we are using what? Table. Now, we now have it 51.38. 2, we have 840.3. 3, we have 65,160. So then, we can now say number 1. Log 10, you can see, log 10 raised by 51.38 is equals to, in 4-figure table, the first thing we will first do, we will first of all look at the characteristics here. Are you getting that? We will first of all check the characteristics. Now, how does this one is 1? That is, we are moving the decimal points here. That's why we have what the characteristics of the integer as what? 1. So afterwards, we now proceed. 51, we now check 51 under what? Under 3. Difference 8. So which now give us what? 7108. So the next one, we look at the characteristics here. We move this decimal point twice. 1, 2. That's why we have 2.9244. Do you get that now? So now, the third one now, if you look at it, there is no decimal point in between. Look at it. Is there a decimal point in between? No. We now assume that our decimal point is here. Is here. We'll now shift the decimal points 4 times. 1, 2, 3, 4. Are you with me? We do it this way, as it is. 1, 2, 3, 4. Look at this one. 1, 2. Can you see that now? So when we now adjust the decimal points 4 times. So in this case, we can now say, how many times do we adjust the decimal point? Which is what? 4 times. Isn't it? So we can now put it by saying that what? 4 points. We now check 65. 65 under what? Under 1. 65 under 1. Difference what? Difference 6. So when we now check that, that's when we have 4.8140. Now, the next step, which is known as what? Anti-log. If we are talking about anti-log, that is, we are dealing with the opposites of a logarithm. When we said opposite of the logarithm, opposite of the logarithm. Now, the opposite of the, remember in English we have word and opposite. So mathematics in logarithm too, we have word and opposite. So now, if we now talk, after getting the logarithm, we have to look for the opposites of what? Of the logarithm. So this is how we have what? Example. Now we now have 0.56. So in checking the antilog of 0.56, so therefore, that is, we are checking the antilog of what we are having. Now here, sorry. So if we are not checking the opposite of the logarithm, that is to say, this integer has to be what? Has to be placed. So here we have what? 0.5. That is to say, we are moving what? That is, we have it 0.1. We have 3. That is, it's telling us that what? This one is 0. What? 10 raised power 0, which is what? 1. So we now are putting there. This one is what? 2. So if we now want to apply our decimal point, that is, we assume that is what? Here. So we now what? We now fix it what? At the middle. So now this is what? 5.3. So after checking your antilog, you now fix it. Okay, 1, 2, 3, 4. 1, 2, 3, 4, 5. You apply it like this. So this is what? This is our anti-log. So next class we are going to see more and more on what? On our logarithm. So viewers, what we need, once you have seen this, please, I beg you, for us to continue in this ministry, please and please, kindly tag us, share us, subscribe to our channel, then you give your comments. If there will be any, please give a comment, and also show those who are your friends, even though it's not related to you or you don't need it. There are some that they are around you that might need it. Please, you can kindly show it to them. Let them understand. Let them have the sweet